There are stars in the sky that do more than shine. They whisper, they flicker with stories not entirely their own. They pulse like forgotten heartbeats, echoing the past across light-dash years. Welcome to journey through the universe's most haunted stars, a voyage unlike any other, a slow drifting descent into the eerie, the mysterious, and the ghostly remnants scattered across the cosmos. This is not a tale of ghosts in the traditional sense, but of celestial objects marked by strange disappearances, violent pasts, spectral lights, and puzzles so ancient they defy explanation. Each chapter will take you closer to stars that behave oddly. Stars that flicker with unpredictable rhythm, or that hide the echoes of their own destruction. Some are solitary wanderers expelled from their birthplaces. Others are trapped in tragic binary dances. Some have gone silent entirely, their last breath still traveling through space. This isn't horror. It's awe wrapped in shadows. Lie back. Let the weight of gravity loosen its grip and drift alongside these haunted suns as we explore their secrets one by one. You are now entering the quiet side of the universe, where even stars are haunted by time. Chapter 1: The Phantom of Betelgeuse. Betelgeuse is no ordinary star. It burns red and massive in the shoulder of Orion, and from Earth its light has shimmered in the night sky for thousands of years. But behind its fiery glow lies a legacy of dread, mystery, and ominous expectations. Astronomers have long watched Betelgeuse with a mix of fascination and anxiety. Because it is a star on the brink of death, Betelgeuse is a red supergiant, bloated and unstable. Its surface is chaotic, with enormous convective cells the size of planets boiling beneath its reddish skin. Sometimes it pulses. Sometimes it dims, and once recently nearly vanished from our sky. In late 2019 and early 2020, Betelgeuse dimmed more than it ever had before in recorded history. The event, now called the Great Dimming, sent waves of speculation through the astronomy community. Had the moment come? Was Betelgeuse finally about to explode into a supernova cosmic detonation that would light our skies for months, even in daylight? But the explosion never came. Instead, Betelgeuse slowly brightened again, as if nothing had happened. The mystery seemed to resolve when astronomers discovered that the dimming was likely caused by a giant cloud of dust, possibly ejected from the star itself, that had temporarily obscured its light. Still, the incident left behind a sense of unease, like the flicker of candlelight in a haunted room. Because the truth is, Betelgeuse will explode. We just don't know when. Its core is fusing heavier and heavier elements, nearing the final phase of its life. One day, the delicate balance of outward pressure and gravitational pull will break, and the star will collapse in on itself before rebounding in a cataclysmic supernova. When that happens, it will be one of the most spectacular cosmic events ever witnessed by humans, and yet the light we see from Betelgeuse is old, over 600 years old, in fact. The star could already be gone. We wouldn't know. The ghost of Betelgeuse could be all that remains, its death having already occurred in the distant past, with the brilliant explosion still on its way to our eyes. This delay in light a feature of cosmic scale gives the star its eerie quality. We may be watching the phantom of a stellar being already lost. It's a haunting concept, this idea that what we observe might no longer exist, and Betelgeuse itself plays the part well. It's dramatic. It shifts unexpectedly. It feels alive in a way stars usually don't. Ancient cultures ascribe spiritual meaning to it. The Egyptians associated it with Osiris, god of the underworld. The Greeks saw it as part of the mighty hunter Orion, whose myth is woven into the fabric of the skies. In medieval times, people believed strange flickering stars were omens, and Betelgeuse has always flickered. In modern times, we wait with instruments and calculations, but still with a primitive curiosity. When will Betelgeuse die? Will we witness its final breath, or are we already watching its ghost? It's hard not to anthropomorphize a star that seems to call attention to itself. There's no malevolence in Betelgeuse's actions, only physics. But there is a kind of drama, an almost performative uncertainty, a sense that something is building just out of sight, just out of reach. In the end, Betelgeuse might be remembered not only as a stellar giant, but as the most theatrical ghost in the cosmos, a phantom of light, a prelude to fire, a mystery, suspended in space and time. Let us move on now, deeper into the shadows of the universe, toward another haunted star whose fate is even more tragic. Chapter 2. The Cursed Heart of Eta Carini. Far to the south, in the constellation Carina, lies a star system wrapped in myth, fury, and Catastrophia Carini, a monstrous binary that has baffled and terrified astronomers for nearly 2 centuries. It is not merely a star. It is a cosmic event in slow motion, a spectacle of chaos wearing the face of grandeur. And at its heart, there is something deeply cursed. Eta Carini is no ordinary celestial body, of which was once thought to be over 100 times the mass of our Sun. This is a system in rebellion against stability, against time, against what we understand stars to be. Surrounded by a massive, expanding cloud of gas and dust known as the Homunculus Nebula, Eta Carini exists in a perpetual state of near destruction. Its legend begins in the 1840s, when Eta Carini brightened suddenly, becoming, for a time, the second brightest star in the night sky. It outshone Rigel, even Sirius. But this was not the light of triumph. It was the desperate blaze of a star ripping itself apart. The event became known as the Great Eruption, during which Eta Carini expelled more than 10 solar masses of material into space in a violent outburst unlike anything seen before or since. And then it faded, not entirely, not into death, but into a strange half-life. It flickered back into obscurity, hiding behind the veil of its own ejected material, shrouded in dust, like a spirit too broken to show its face. The light we now see from Eta Carini is filtered through this ghostly fog, giving it a blurred, spectral glow. It looks haunted. For decades after the Great Eruption, astronomers believed the star had exploded into a supernova. It should have. By all logic, Eta Carini should be long gone. But somehow it survived, wounded, unstable, yet burning on. And therein lies the horror. It didn't die when it was supposed to. What's left is a system in tension. The massive primary star is on the edge of collapse, and its companions smaller, but still huge whips around it in an eccentric orbit every 5.5 years. Their interactions are extreme. At periastrant, the point of closest approach, winds from the two stars clash at speeds of millions of kilometers per hour, generating X-rays and shock waves that rattle the surrounding nebula. Sometimes those X-rays vanish suddenly. It's as if the star is holding its breath. The silence is unnerving, and always there is the possibility lingering, patient, that Eta Carini may go supernova, or worse, it may become a hypernova, an explosion even, more violent, with the potential to form a black hole and release deadly gamma-ray bursts. If it does, and if one of those bursts is aimed at Earth, it could affect life here in ways we've never encountered before. This is not science fiction. This is a real possibility, one that keeps astronomers awake at night. What haunts us about Eta Carini is not just its power, but its unpredictability. It is a star that should have died, that tried to die, but failed. It lingers like a wounded animal in the cosmic dark, its future uncertain, its past unresolved. The Homunculus Nebula, shaped like a pair of ghostly wings, seems to frame this tragedy. It glows in infrared and reflects the violence of the past, whispering of the eruption like a permanent scar on the universe. Ancient cultures never saw Eta Carini the way we do now. But if they had, they may have spoken of it as a cursed, heart beating irregularly, glowing with sorrow, waiting for the final stroke that would shatter it completely. For now, it endures, but it is only a matter of time. Let us drift further, now to a lonelier corner of the cosmos where another star holds secrets of death and rebirth, and where its very expansion seems to echo the arrival of something lost. Chapter 3. V838 Monocerotis, the star that swallowed a ghost dot deep in the quiet folds of the constellation Monoceros. The unicorn lurks, a star that did something utterly unexpected. It did not explode. It did not collapse. It expanded swiftly, violently, and with no warning. Its outburst wasn't bright in the usual way. It was strange, spreading through the fabric of space like a ripple in a pond, as if it had swallowed something it couldn't quite digest. Its name is V838 Monocerotis, and its story remains one of the most perplexing and ghostly stellar events ever observed. In January of 2002, V838 Monocerotis, an unremarkable star only faintly known to astronomers, suddenly erupted. It brightened by a factor of nearly 10,000 in just a matter of days. But this wasn't a supernova. It didn't blast its outer layers into oblivion. Instead, the star swelled, its surface temperature dropped, and it became a luminous red supergiant, briefly one of the largest stars in the entire galaxy. But the real mystery came after. What followed the outburst was a phenomenon called a light, echo's spherical shell of illumination expanding through the surrounding interstellar dust. As light from the eruption hit these clouds, it scattered and reflected toward Earth in a series of glowing, ever-growing rings. It looked like the ghost of the star was expanding through space, like something ethereal had been released, stretching outward in slow motion. Each frame, captured by the Hubble Space Telescope, showed V838 Mon in a new, haunting form, like watching an echo of light travel through ancient darkness. Some described it as watching a haunting unfold in the vacuum of space. And still, no one truly knows what caused it. Was it a stellar merger? Did V838 Monocerotis absorb a smaller companion star, triggering the outburst? Was it a planetary engulfment, some massive gas giant falling into the star's core, or something even stranger? One of the leading theories suggests that V838 Mon's eruption was caused by the consumption of a star celestial cannibalism. Two stars spiraling toward each other in a doomed dance, finally colliding in an event that didn't destroy, but transformed. If true, we are witnessing not just a death, but a violent union. The birth of a ghost. The aftermath is eerie. The 838 Mon is now shrouded in dust, its true form partially hidden, its light still echoing outward through space. The event may never repeat in exactly the same way. We caught it in a moment of transformation, stellar exorcism caught in real time. And then there's the shape of the echo itself. It is round, almost too perfect, as if the star was enveloped by something ancient, something waiting. The tendrils of dust, the soft arcs of reflected light, they do not just illuminate. They suggest presence, memory, like the star was not alone when it changed, like it touched something. To gaze upon the images of V838 Mon is to feel distance and wonder. Yes, but also something more, a chill, perhaps, an awareness that even in the most sterile regions of space, something unexpected can stir. Stars can behave like ghosts, not by disappearing, but by expanding into memory. Now the light echoes continue to drift outward, a ghost story in progress. Each year, new layers of ancient dust are lit, revealing the forgotten structure of space around the star-like, illuminating a cosmic graveyard, one veil at a time. And yet V838 Monoceratus remains silent, still swollen. Let us move forward once again, this time to a star that has captivated humanity since Antiquity, crimson traveler whose flickering light has always hinted at something unnatural. Chapter 4. The Witchlight of Mira among the ancient stars, visible to the naked eye. Few have mystified observers as deeply or as persistently as Mira, the wonderful star. For thousands of years, its strange, flickering presence has risen and vanished in the skies, earning it a place in mythology, astrology, and early astronomy alike. But behind Mira's beauty lies a turbulent secret. It is dying, slowly and eerily, leaving behind a glowing trail like the wake of a ghost ship. Across the ocean of space, located in the constellation Cetus, the sea monster Mira is a red giant nearing the end of its life. It is also the prototype of a whole class of variable stars, Mira variable stars, that rhythmically brighten and dim over long periods. But Mira is not just any variable star. It disappears. To the naked eye, it can go from being one of the brightest stars in its region to nearly invisible, and then back again over a cycle of about 332 days too early skywatchers. This behavior was unexplainable and unsettling. Mira's changes were first recorded by the Dutch astronomer David Fabricius in 1596, but it was centuries before astronomers began to understand the cause of its vanishing act. What we now know is that Mira is pulsating. Its outer layers expand and cool, then contract and heat up again and again. These shifts affect its brightness as seen from Earth. But even with this scientific clarity, there's something distinctly supernatural in its behavior. Because Mira doesn't just flicker like a candle. It breathes like a dying entity. And then, in 2007, NASA's Galaxy Evolution Explorer, GALEX, revealed something that only deepened the mystery. Trailing behind Mira is a tailor, ghostly, glowing filament, 13 light-years long. Invisible to human eyes, but brilliant in ultraviolet. Mira, in its death throes, is shedding itself into space, leaving behind a cosmic ribbon of plasma and dust. It's the only known star with such a tail. The tail is formed as Mira speeds through the interstellar medium at about 130 kilometers per second, a runaway star leaving behind the exhalations of its fading life. It is essentially a stellar haunting your trace of presence stretching out behind it, visible only in certain wavelengths, like the lingering aura of something no longer alive. And yet, Mira lives. For now, it is part of a binary system. Its companion, a hot white dwarf, orbits closely, siphoning off some of Mira's material. This relationship is both intimate and vampiric. The dwarf feeds on the red giant's atmosphere, glowing faintly as it grows quietly, participating in Mira's slow undoing. Some astronomers believe that when Mira finally sheds enough mass, what remains may briefly ignite into a nova flash of stolen light before total darkness. Others think it will simply collapse into a dense white dwarf, cold and inert, a whisper of its former self. But what haunts most is not its endings, its motion. Imagine it, a star dying for millennia, drifting through space, shedding light no one sees except in ultraviolet. It vanishes and reappears like a phantom in a dream, its orbit unseen, its tail invisible. To the eye, it flickers. To the telescope, it is a comet of sorrow, a thing falling apart but still burning dot in ancient Persia. Mira was considered a bad omen. In Babylon, a celestial wanderer. Even today, stargazers report a strange sense of presence when watching it, especially during its dimmest moments when the eye strains to find it, and yet something feels there is not malevolent. But it is not benign. It is a light that refuses to die quickly, a soul unraveling across space, always moving, always changing. A crimson ghost that breathes once a year. And so we turn now from this stellar witchlight to another haunted heart, one that should not exist at all. A star, so strange, it blurs the line between life and death, between star and corpse. Chapter 5. Thorn Kit Cow Objects Haunted Hybrid Stars. Some stars are strange, others are cursed. And then there are those that seem stitched together, natural fusions born of stellar violence, wandering through space like Frankenstein's monster. Among the rarest and most speculative of all are the enigmatic Thorn Kit Cow objects, or TZOs, stars that contain the collapsed corpse of another star buried inside them, if ever a star could be considered possessed. This is it, first theorized in the 1970s by Kip Thorne and Anna Kitcow. These haunting hybrids are thought to form when a neutron star remnant core left after a supernova falls into the core of a massive red supergiant, rather than merging instantly. The neutron star spirals inward through the supergiant's envelope, eventually embedding itself deep inside, like a spectral parasite occupying a living host. The result is a chimeric being, part red giant, part neutron star. The outer layers appear normal, a glowing, swollen supergiant lies a collapsed core of unimaginable density to an observer. A TZO may look deceptively serene, but the reality is far stranger. In its heart, atomic nuclei are being torn apart under pressures far greater than in ordinary stars. The embedded neutron star doesn't accrete matter in the usual way. Instead, it slowly alters the internal structure of its host, generating unusual nuclear reactions. The fusion process becomes warp-producing exotic elements rarely seen in nature, like lithium and rubidium, in strange and disproportionate quantities. This chemical fingerprint may be the only clue to the object's true identity. A whisper, a trace, a soft knocking from within. Only one real candidate for a TZO has ever been observed. HV 2112. Located in the Small Magellanic Cloud in 2014. Astronomers found it emitting spectral lines matching the bizarre elemental output predicted by Thorne and Jitko's original theory. It was dimmer than expected and irregular in its activity, like a being struggling to maintain control over its own structure. But even HV 2112's status remains uncertain. TZOs may be so rare, so short-lived, that we will never truly see one again. Or worse, they may be more common than we think, hiding behind the illusion of normality. Imagine a star glowing peacefully in the night sky. Now imagine that star is being inhabited by the ghost of a collapsed sun. Its outer layers whispering all is well, while deep within, matter is crushed into neutronium, and memories of a violent supernova are replayed in silence. The terror of the Thorn Kitcow object lies not in destruction, but in its persistence. These stars are not exploding. They are not dying in flames. They are surviving, but wrong, unstable, warped, haunted by their own origin. They have swallowed death and now carry it with them forever. And what happens when the balance fails? Some theories suggest that the neutron core might eventually cause the whole object to collapse into a black hole, devouring the envelope in a final, silent implosion. Others believe the object might slowly fade into obscurity, leaving behind a trail of unnatural elements as its only tombstone. For now, they remain mostly theoretical ghost stories told by physicists, lurking between the pages of stellar evolution textbooks. But one thing is clear: if stars could harbor secrets, none would be darker than this. Let us move now to another spectral source, not a hybrid, but a remnant, a broken echo of a star's final scream that still pulses faintly through the void, the ashes of a cosmic fire, still glowing with memory. Chapter 6: The Echoes of Cassiopeia A. There are places in the universe where time seems to hesitate, where the violence of the past refuses to fade, echoing through the dark like the faint tolling of a long-dead bell. One such place lies within the boundaries of the northern constellation Cassiopeia, where a cloud of dust and shattered gas continues to glow with a memory of a star's death. This is Cassiopeia A, the ghost of a supernova. What makes Cassiopeia A so eerie is not merely that it is a remnant of a stellar explosion. It's that the explosion was silent for us. The original star died over 11,000 light-years away, based on the age of the expanding cloud. The supernova likely occurred around the late 1600s, and yet there are no reliable historical records of anyone on Earth witnessing the explosion, not even a whisper in ancient chronicles. No sudden light in the sky noted by astrologers or monks. Why not? Was it obscured by interstellar dust? Did clouds of gas along our line of sight hide the event from view? Or was it just a brief flare overlooked in an era before telescopes could scan the heavens continuously? Whatever the reason, we never saw its death, only the aftermath. Cassiopeia A is now the brightest radio source in the sky outside our solar system at certain frequencies. It glows in X-rays in infrared, in radio waves. It pulses not like a living star, but like an echo rebounding off cold stone. The expanding shell of debris hurtles outward at 4,000 kilometers per second, carrying within it clues about the inner workings of the explosion. And in the center, astronomers discovered something even more chilling. Buried within the cloud is a neutron star, possibly with an unusually cool surface, a compact object left behind by the blast, radiating in X-rays, but strangely quiet otherwise. It has no detectable pulsations, no strong magnetic field, just presence, like a tombstone in the center of a storm. It is often called the Central Compact Object, or CC. What we know about it is limited. It does not spin like a pulsar. It is as if the soul of the star was ripped out, but the corpse lingers. What's more, modern imaging from NASA's Chandra X-ray Observatory has revealed something almost poetic. Over time, we can watch the shock waves move frame by frame, year by years, if the star's final scream is still unfolding before us. It is the closest thing we have to a slow-motion replay of a stellar death. A cosmic obituary written in glowing gas. The colors in Cassiopeia A are beautiful. Hues of green and blue from oxygen, red from sulfur, gold from silicon and iron. But this is not the beauty of creation. It is the beauty of ruin. In some ways, Cassiopeia A is a haunted house, a structure broken by trauma, filled with spectral emissions, and housing a silent occupant in its center. It reminds us that when stars die, their story does not end. It expands, it darkens, it echoes. One can imagine the ghost of the star still drifting through the remnants, its final light bouncing off the dust it once gave birth to. And every year, we detect slight changes, whispers of motion, like the remnants are still reacting to something that's already gone. Astronomers listen closely to Cassiopeia, hoping to decode its secrets, to understand how it died, why it left behind something so still, so odd, so wrong. In the meantime, ghost glows on. Let us now drift farther across the sky, toward a dazzling and violent giant whose blue flame hides a tale of speed, solitude, and spectral light. Chapter 7. The Blue Ghost of Zeta Puppis. Some stars haunt not because they're dead, but because they are fleeing. Running from something, or perhaps from nothing at all, with a speed so unnatural that even the heavens seem to recoil. Is the case with Zeta Puppis, one of the most massive, luminous, and loneliest stars in our part of the galaxy. It races through the cosmos like a ghost on fire. Zeta Puppis is a hot blue supergiant located in the constellation Puppis. the stern of the ancient ship Argo Novice. It burns at a temperature of nearly 40,000 degrees Kelvin, several times hotter than our sun, and emits tens of thousands of times more light. Its radiation scours space around it, peeling atoms apart, pushing material outward in powerful stellar winds. But the light isn't the strangest thing about it. It's the motion. Zeta Puppis is a runaway stellar vagabond. It's moving through space at a breakneck speed of over 60 kilometers per second, far faster than normal stars in its neighborhood. Astronomers believe it was violently ejected from its original birthplace in a gravitational tragedy long ago. There are two leading theories for how this happened. One possibility is a supernova companion, a binary star system where Zeta Puppis once orbited a massive partner. When that partner exploded in a supernova, the gravitational tether snapped. Zeta was flung away like shrapnel, still burning, still alive, but utterly alone. The ghost of its companion likely became a neutron star, perhaps even a pulsar, forever separated. That the second theory is dynamical ejection, a chaotic interaction within a densely packed star cluster where multiple massive stars interacted gravitationally. In this cosmic brawl, Zeta was kicked out with terrifying velocity, like a soul banished from its home. In either case, the story is tragic. Zeta Puppis is a refugee, cast adrift by violence. It blazes through the galaxy, burning through its fuel. In a furious rush, blue giants like Zeta live fast and die young. They don't last long, just a few million years. Zeta has already lived through most of its brief lifespan. Its winds are some of the strongest known. These winds create a kind of invisible wake, like the ripples behind a boat sept. This wake is sculpted in ionized gas and plasma, glowing faintly in ultraviolet. If we could see it properly, Zeta Puppis would appear not as a single point of light, but as a comet of fire, a streaking soul trailing a ghostly veil. There is something unsettling about its solitude. It has no companions, no cluster siblings. It races forward through the galactic disk as if pursued by silence itself. It will likely explode in a supernova far from where it began, lighting up some forgotten corner of the Milky Way in one final act of cosmic rebellion. But even now, before that inevitable end, Zeta Puppis haunts us. Its very presence is a reminder of disruption, a star that doesn't belong where it is, a blue flame without a home. To look at Zeta Puppis is to glimpse a cosmic exile, a stellar ghost in the making, an object still alive, but marked by a past it can never return to. And when it finally dies, it may leave behind not just a neutron star or black hole, but a new runaway ejected from its explosion, continuing the cycle. A lineage of haunted light tearing through space, forever untethered. Let us now turn our attention to a ghost far older, one whose final breath was recorded by ancient eyes and whose spectral remains still shimmer in the dark. Chapter 8. The Dying Breath of SN 1054. Sometimes a ghost announces itself with a roar. Sometimes the sky keeps the memory forever. In the year 1054, long before the telescope was invented, a star exploded on the heavens, changed for weeks. It outshone everything except the sun and moon. Ancient Chinese astronomers recorded it as a guest star in the constellation Taurus, visible even in daylight. Native American petroglyphs may depict it as well etched into canyon walls as a bright point beside the crescent moon. But eventually, the light faded, and the object that caused it vanished from human memory. Except it didn't vanish at all. It simply transformed today. We call it SN 1050 for the supernova that gave birth to one of the most haunting celestial relics in the known universe. The Crab Nebula, located about 6,500 light-years away. The Crab Nebula is a swirling cloud of debris expanding from the site of that ancient explosion. Invisible light. It appears as a tangled web of filaments, pale reds and soft greens, stretching outward like the remains of some cosmic chrysalis. But the true horror, the eerie beauty, lies within. At the very center of the nebula is a pulsar, a neutron star rotating 30 times per second, firing beams of radiation through space like a lighthouse for the dead. This remnant is the core of the original star, compressed into a sphere just a few kilometers wide, but heavier than the entire sun. It is a corpse still moving, still glowing, its energy sustaining the glow of the nebula centuries after the explosion. You are watching a ghost breathe. The Crab Pulsar pulses in gamma rays, in radio frequencies. Its light reaches us in regular beats, artificial, almost machine-like, yet driven entirely by the mechanics of collapse. It is the dead star's last act, a rhythmic, silent scream echoing through the void. And the nebula. It changes, slowly, visibly, year by year. The outer layers continue to expand, pushing through space at thousands of kilometers per second. The tendrils of gas twist and curl like vapor trailing from something hot and fading. It's as if the explosion is still happening, just stretched across time and distance. Astronomers can point their instruments at the Crab Nebula and watch history unfold. They can see what the ancient Chinese observers saw in reverse. They witness the lingering breath of an event long past, glowing in the darkness, refusing to fade. And yet, the eeriness doesn't end with observation. There's something unsettling about the crab's consistencies. Central pulsar spinning with such precision that it became one of the earliest cosmic clocks. But then, occasionally, something interrupts it. A glitch. A sudden, brief change in the spin rate, as if the star hiccups, or twitches, or ... resists. Why? Some believe these glitches are due to starquake sudden shifts in the crust of the neutron star caused by internal pressure. But we don't fully understand them. Okay? We only know that they happen unpredictably, like tremors from beneath the grave. There's also the question of what came before. The progenitor of SN 1054 was likely a massive star at the end of its life, already unstable, possibly surrounded by shells of material ejected in its final days. Did it know its death was near? Was the explosion sudden, or did it come in waves? Like breathing, slowed to its final gasp. In the silence of modern space observatories, we search the remains for answers, and all the while, the nebula glows. The Crab Nebula is not a star. It is the memory of a star, a monument to celestial collapse, a death so loud its echoes still light up the sky. And now, we move toward something stranger, still not the remnants of a single death, but the erratic, restless souls of collapsed stars trapped in ghostly motion. Chapter 9. The poltergeist pulsars of the Vela constellation. Some remnants of dead stars flicker, others pulse. But within the constellation Vela, in the southern sky, lies a cluster of stellar ghosts that do something more disturbing. They twitch, they glitch, they defy rhythm. And at the heart of them is the Vela Pulsar 1, of the most studied and erratic neutron stars in the cosmos. Welcome to the domain of the poltergeist pulsars. The Vela Pulsar was born in fire specifically, from a supernova that exploded roughly 11,000 years ago. The echo of that blast still drifts across space as the Vela supernova remnant, a diffuse cloud of hot gas expanding in eerie silence. But it's not the cloud that haunts astronomers. It's what lies at its core. The pulsar itself is a spinning neutron star about 20 kilometers in diameter, rotating more than 11 times per second. It emits beams of electromagnetic radiation from its magnetic poles. And when these beams sweep past Earth, they flash like a lighthouse in the void. But unlike most pulsars, the Vela pulsar doesn't behave consistently. It doesn't keep a perfect beat. Every few years, something strange happens. Its rotation suddenly speeds up, abruptly, without warning. In an instant, this phenomenon is known as a glitch. And while it may sound minor, It's a profound clue to the inner structure of a neutron star. Scientists believe that beneath the crust of the pulsar lies a superfluida, bizarre state of matter where friction ceases to exist. As this superfluid rotates independently from the crust, it stores angular momentum. Eventually, that stored momentum transfers to the outer layers, causing the sudden spin-up, but it feels unnatural, like a twitch, like something trapped inside, shifting restlessly. The Vela pulsar has glitched over a dozen times since its discovery in 1968. Each event is unpredictable. Sudden, it's like the star is spasming in its sleep. And though it is long dead, these bursts of motion suggest a kind of ongoing ... tension. A body at rest does not twitch. Only a haunted one does. And the Vela region is full of these restless spirits. Several other pulsars reside nearby, within the tangled remnants of the old supernova. Each carries its own beat, its own slight irregularities. One has a wobble, another emits strange X-ray pulses. It's as if the whole region is charged with the memory of the explosioning area of space where silence never fully settled in. Some ways, this cluster resembles a stellar asylum, fractured remnants of once mighty stars, spinning uncontrollably, flashing in distress. Not random, not calm, agitated. Adding to the strangeness is the Vela supernova remnant itself, a ghostly structure of shocked gas and filaments glowing in radio and X-ray bands. It doesn't fade like typical remnants. It seethes, torn, as if still reacting to an explosion that occurred thousands of years ago. The energy from the central pulsar continues to power parts of the cloud, like electricity through a nervous system long after death. And then there's the sound. Radio telescopes have translated the pulsar's flashes into audible pulses. When you listen, it resembles a heartbeat with a stutter. A ticking clock that sometimes skips forward, uninvited, unannounced. A nervous tick from beyond the grave. To observe the Vela pulsar is to sense unease. It is not simply a relic. It is an ongoing process of decay and reaction. A remnant star that refuses to settle into final silence. Something inside it won't stop moving. Perhaps that's the greatest horror of all. Not that the star died, but that it keeps trying to live. Now we drift onward, away from this nerve center of stellar unrest, toward a different kind of haunting one, where the light of a star dims unpredictably, as if suffocating from within. Chapter 10. The Flickering Curse of our Coronae Borealis. In the quiet northern constellation of Corona Borealis, nestled among the stars of the celestial crown, lies a peculiar and temperamental sun. It is not especially bright, nor especially Close, yet it has mystified astronomers for over 2 centuries with behavior so strange, so inconsistent, that it almost seems alive. This is our Coronae Borealis, and it is cursed, not by myth or legend, but by its own internal chemistry. A star that flickers not in regular pulses like a pulsar, but in deep, unpredictable plunges, as if something were extinguishing its light from within. At first glance, our Coronae Borealis, or RCRB, looks like an ordinary yellow supergiant, but that's only during its calm phases. Without warning and without periodicity, the star can fade by up to 8 magnitudes, nearly disappearing from the night sky altogether. And then, just as mysteriously, it begins to brighten again, slowly, sometimes over months or even years. This behavior is not like that of a variable star with a known cycle. It's sporadic, chaotic, almost willful. To ancient observers, it would have looked like a star dying and resurrecting over and over again. So what causes this eerie vanishing act? The answer lies not in the star's core but in its skin. RCRB belongs to a rare class of stars known as hydrogen-deficient carbon stars. These are old, evolved stars that lack hydrogen in their atmospheres and are instead rich in carbon, an unusual composition that sets them apart from most other stars. Over time, this carbon forms thick clouds of carbon soot. Much like cosmic smoke, occasionally, for reasons not fully understood, the star expels a puff of carbon into its atmosphere. These particles condense into clouds, which then drift in front of the star, blocking its light. From Earth, it looks like the star is dimming, but in reality, it's being suffocated by its own breath. Imagine a lantern that occasionally releases its own smoke, blinding itself from view, and this cycle continues unpredictably. Sometimes RCRB fades for weeks, sometimes for years. There is no rhythm-only flickering uncertainty. What's haunting is that we don't fully understand why these carbon ejections occur. Are they triggered by internal instabilities, subtle pulsations in the star's core? Or is it some slow-motion chemical unraveling, like a body quietly falling apart, cell by cell? Whatever the cause, the effect is ghost-like, a star vanishing behind a veil of its own making, like a haunted figure retreating behind smoke. Some astronomers believe RCRB may be the result of a stellar merger, white dwarf colliding with another, forming this hydrogen, carbon-rich anomaly. If true, then RCRB is not just Odit's reborn, its current self, the aftermath of a cosmic tragedy. A hybrid of 2 collapsed lives, now unstable, unpredictable, and fading, and it's not alone. There are a few dozen known RCR-B-type stars across the galaxy, all exhibiting similar flickering behaviors. Together, they are like a secret society of dying embers, each fading in its own strange way. Each a candle that cannot decide when we observe our coronae borealis. We witness not a steady burn, but a struggle, a flicker, a tension between visibility and absence, between presence and memory. It is not dead, but it is dimming, slowly, repeatedly, as if the universe is reminding us, not all hauntings come from what is gone. Some come from what fights to stay, and so, from this star that erases itself again and again, we journey onward to another restless spirit, one exiled from its home, racing through space as though chased by the remnants of its past. Chapter 11. The Wandering Wraith of HD 271,791. Asterisk, imagine a star so fast it is being ejected from the galaxy. A luminous traveler with no home, no companions, and no destination. Just speed, silence, and a trail of mystery. This is HD 271,791, a hypervelocity star, perhaps one of the loneliest and most haunted objects in the entire Milky Way. HD 271,791 dwells in the outer reaches of our galaxy. In the constellation Puppis, though it was not born there, this blue-white star is hurtling through space at over 530 kilometers per second fast, enough to escape the gravitational pull of the Milky Way. And yet, it shows no signs of chaos, no signs of distress. It glows like any ordinary B-type star, except for the speed. That speed is its scream. So how did it come to be a cosmic fugitive? The most compelling theory suggests a tragedy. HD 271,791 may have once belonged to a binary system. It had a massive companion, perhaps a giant star on the verge of collapse. When that companion exploded in a supernova, the system was torn apart. The blast kicked HD 271,791 away like shrapnel. It was not destroyed, but flung. Banished, another theory paints an even darker picture. What if HD 271,791 was expelled, not by a dying companion, but by a close encounter with a black hole? If it wandered too close to the supermassive black hole at the center of our galaxy, the intense gravitational forces could have ripped apart its system and slingshotted the star outward with incomprehensible speed. A galactic exorcism in either case. HD 271,791 is now a ghost ship sailing the galactic sea, away from everything it once knew. It does not pulse like a neutron star. It does not flicker like a dying ember. It burns steadily, classically, as if unaware of its exile. And yet, when we peer into its spectrum, we find clues to its haunted past, unusual chemical signatures, signs of contamination from its former companion's supernova. The explosion that flung it into space also marked it like ash left on the clothes of a survivor. This is a star that remembers. Astronomers call it a runaway. But it's more than that. It is haunted by speed. Not because it moves, but because of why it moves. And where does it go? Outward. Always outward. If it escapes the gravitational well of the galaxy, it will drift into intergalactic space, eternal. Lightless ocean where stars are few and time stretches thin. It will never return. It will never be found again by its stellar kindred. Its light may someday fade into the background noise of the cosmos, unobserved, unremembered. But for now, we see it, and we understand what it is. Not a star, simply in motion, but a star escaping. Its presence is a warning carved in light. Even the most stable stars can be torn from their places, cast into exile by unseen violence. Even the calmest stars can have haunted origins. Let us now drift from this fast-fading traveler to a different kind of ghost one, so bizarre, so intense. It pulses like a heart trapped between dimensions. A zombie star whose rhythms defy logic and light. Chapter 12. The Zombie Beacon of PSRB 1931 plus 24. Asterisk. There are stars that flicker, stars that explode, stars that explode, stars that flee. And then there is a star that behaves like it's been resurrected, switching itself on and off as if caught between life and death, like a light bulb flickering in an abandoned corridor. Its name is PSRB 1931 plus 24, and it is known as the Zombie Pulsar, discovered in 2001. PSRB 1931 plus 24 is a pulsar kind of a neutron star left behind after a supernova, rapidly spinning and emitting beams of radiation. Normally, pulsars pulse with exquisite regularity, their beams flashing toward Earth like the ticking of an atomic clock. But not this one. This pulsar has a pulse that dies and revives, in a cycle that defies conventional physics. For about 5 to 10 days, PSRB 1931 plus 24 emits strong radio pulses like a normal pulsar. Then, abruptly, it stops completely for the next 25 to 35 days. It is silent, no signal, no pulse, no trace, as if the star has died. And then, just as mysteriously, it returns, alive again, spinning, beaming, dot, and this pattern repeats, over and over, like a ghost returning to haunt its old house on a schedule no one understands. Astronomers were stunned when they first realized what they were seeing. Never before had a pulsar shown such intermittent behavior, not like a flicker, not like a glitch, but a true binary state. On, off, a celestial heartbeat that sometimes stops entirely and then starts again, almost as if being reanimated. So what causes this death and resurrection? One theory suggests the pulsar's magnetic field is interacting with a surrounding disk of plasma, or perhaps remnants of the supernova that created it. This interaction could be choking off the pulsar's radio beam, effectively silencing it. Nothing about a chaotic post-supernova environment should produce such stable intervals. Another theory is far more unsettling, that PSRB 1931 plus 24 switches between two different states of physics. In one state, it emits radiation. In the other, the mechanisms inside the neutron star shift subtly, like a heartbeat, pausing, rendering it undetectable. The processes that generate the beam may stop altogether, only to reboot when internal conditions change again. To some, it's as though the star is trying to die, but keeps failing, and the implications are disturbing. Because if one pulsar can do this, how many others might be doing the same? Pulsars we think are dead might only be asleep, waiting to awaken again. Some might already be flashing, but silently. In spectra, we haven't yet discovered PSRB 1931 plus 24 is now considered one of the most enigmatic objects in radio astronomy, part-time pulsar that blurs the line between life and stellar death. But to listen to its pattern is to hear something unnatural. You can chart its cycle. You can observe its silences, but you can't explain the why. Why does it vanish? Why does it return? What changes inside a neutron star that should be long dead? It pulses like a memory. It disappears like a breath. It returns like a ghost. It's not alive, but perhaps something inside it still remembers what it means to shine. And so we journey onward, this time to a star wrapped in a shroud, not of dust or carbon, but of mystery. A fading beacon at the heart of a forgotten nebula, hiding secrets deeper than even its death can reveal. Chapter 13. The Shrouded Secret of Epsilon Aurigae. Among the thousands of stars visible to the naked eye, few are as unsettling as Epsilon Aurigae's seemingly ordinary point of light in the constellation Auriga, the charioteer. For centuries, it flickered just faintly, modest in appearance, but steady. And then, every 27 years, it fades, for nearly 2 whole years. Not in fits or pulses, not erratically, but in a slow, smooth, calculated eclipse. As if something vast and dark were silently passing in front of it. But what, Epsilon Rij, has baffled astronomers since the 1800s, when they first noticed the eerie pattern of its dimming. The light of this bright F-type supergiant dims by almost 50% every 27.1 years, then returns to normal, as though nothing ever happened. This isn't a brief blink. This is a prolonged shadow, and for much of the last 2 centuries, no one truly knew what was causing it. Initially, astronomers assumed a binary system. Epsilon Aurigae must have a companion star that periodically eclipses it. But here's the problem. Even the largest known stars wouldn't block Epsilon's light so completely, for so long, without being visible themselves. Whatever the object was, it wasn't glowing, it wasn't shining, it was hiding. Eventually, the leading theory emerged. The eclipsing body is not a single star, but a massive dark disk of dust, orbiting a hidden companion, possibly a B-type star or a pair of smaller stars, veiled in the disk's shroud. A structure so enormous it spans billions of kilometers, yet so thin and opaque it blocks half the light of a supergiant. Imagine a star being eclipsed not by a planet, but by a cosmic monolith. A flat, cold, dark sheet of mystery. Infrared observations support the idea there is thermal emission heat, not light radiating from the eclipsing body, consistent with a vast ring or disk of dust. This disk is not edge-on, tilted like a blade sliding across a beam of light. Its slow passage explains the gentle fade and return. But what created this disk? How does it remain stable over centuries? And what exactly lies within? Some suggest we are witnessing the remnants of a stellar merger, the final stages of 2 stars collapsing into each other, surrounded by a veil of debris. Others believe the disk may be part of a planetary system on a grand scale, far beyond what we see in our own solar neighborhood. Still others whisper more unsettling possibilities, that it is a failed stellar nursery, a collapsing mass that never fully formed, hovering between existence and decay. Or that the hidden companion itself is a dying object, white dwarf or neutron star, cloaked in dust, lurking at the edge of visibility. And then there's the symmetry, the precision of the eclipse timing. It occurs with near-perfect regularity, like clockwork. This haunting clock, ticking once every 27 years, never missing a chime. Epsilon Aurigay doesn't flicker like a dying flame. It dims like a memory. A remembrance that returns on cue, like an anniversary of something no longer spoken of. For centuries, humans have looked at this star and sensed a presence behind it. Not malevolent, but heavy, deliberate. A slow blink from something ancient and watching. When Epsilon Aurigay dims, again likely around the year 2036, astronomers will once more aim their instruments at it. They will search for signs, for motion in the disk, for shifts in the hidden light. But some mysteries are not meant to be fully solved. Some stars carry secrets not in their light, but in their shadows. Let us now drift into a darker region of space, where the very concept of light and heat collapses. A cold, wandering relic, no longer even a star, but still capable of haunting with its silent path. Chapter 14. The Cold Ghost of Waizu 8550714. Asterisk. What if a star died so completely it forgot how to shine? In the frozen shadows, just 7.2 light-years from Earth, closer than many of the stars we see in the night sky, drifts one of the coldest, darkest, most unsettling objects ever discovered in space. Its name is a string of numbers, WISEO 8550714, but you could call it a ghost. Technically, it's not even a star anymore. It's a brown dwarf, failed star, born with just enough mass to try fusing atoms, but never enough to succeed. These objects hover in a liminal space between planets and stars, neither alive nor fully dead. They glow faintly in infrared, invisible to the human eye. And WISEO 8550714 is the coldest one we've ever found. Its temperature is barely 17 degrees Celsius colder than the freezing point of water, colder than the surface of Mars, colder than your kitchen freezer. And yet, it's not a rock or a planet. It's a substellar object, a star that could have been, drifting alone through the cosmos. When it was discovered in 2014 by NASA's WISE mission, astronomers could barely detect it. It emits no visible light, no pulse, no flicker, only a whisper of heat seen through infrared lenses. It is nearly featureless, nearly silent, a relic from an earlier time in the galaxy. Its surface may contain water clouds, the first ever detected beyond our solar system. Imagine that, a ghost star cloaked in freezing, silvery clouds, drifting without orbit, without light. A star with clouds, but no flame beneath them. It is likely billions of years old, ancient, even by stellar standards. It has had time to cool, to slow, to forget. It no longer even pretends to be a star. And yet, it moves. WISE 08550714 is not anchored to any solar system. It's not circling a sun. It's wandering, a nomad among the stars. A rogue object that may have been ejected from its birthplace long ago. Perhaps it once belonged to a star cluster. Perhaps it was expelled during the violent early days of the Milky Way. Perhaps it never had a home at all. There's something deeply haunting about that. It is one of the closest substellar objects to Earth. Yet invisible, it could drift past a telescope's field of view and leave no trace, no signature to reflect, no signature to betray its presence. Only cold, only silence. We only found it because it still leaks heat, like a dying coal buried in cosmic ash. And one day, even that may fade. WISE 08550714 reminds us that not all ghosts are remnants of destruction. Some are failures of creation, things that never fully became what they were meant to be. It is not the echo of an explosion. It is the absence of a flame, and in that absence it haunts what other wanderers drift nearby unseen. What other cold souls are passing through the dark between stars, waiting to be noticed if only once before vanishing again? Let us leave this frozen spirit and look skyward to a far more violent ghost star so massive and unstable it threatens to go supernova before our very eyes, dimming and brightening as if fighting its own inevitable death. Chapter 15. The Doomed Giant of Betelgeuse. It looms in the shoulder of Orion like a swollen ember Betelgeuse. The fiery red giant, one of the brightest stars in our night sky. To the unaided eye, it is bold, steady, and iconic. But beneath its glow lies instability, trembling, pressure. Betelgeuse is a star that is dying in real time. A cosmic giant counting down to a spectacular and violent end. Roughly 700 light-years from Earth. Betelgeuse is a red supergiant, among the largest stars ever observed. If placed at the center of our solar system, its bloated surface would extend beyond the orbit of Jupiter. And yet, for all its size and radiance, Betelgeuse is a star in its final act, its nuclear furnace running out of fuel, its core becoming heavy with iron, its outer layers convulsing like a beating heart in cardiac arrest. But something strange began happening in recent years. In late 2019 and early 2020, astronomers around the world noticed something startling. Betelgeuse dimmed dramatically. Its brightness dropped by nearly 60%, enough that the casual stargazer could notice its fading. For a brief moment, one of the sky's most familiar beacons, looked sick, haunted, as if its inner death were beginning to show on its surface. Speculation exploded. Was this the prelude to a supernova? In reality, Betelgeuse's fading was likely caused by a massive ejection of material, a huge plume of gas and dust belched from its surface, which then cooled and temporarily obscured the star's light. But that ejection itself was abnormal. A star this unstable, unpredictable, Betelgeuse pulses. It swells and contracts like an organic thing. Its surface is turbulent, boiling with giant convective cells the size of planets. Cast-off material, forming irregular clouds that drift outward into the void. Imagine a star slowly shaking itself apart, and we watch, we wait, because one day soon, in astronomical terms, Betelgeuse will die when its core can no longer support the pressure of its own mass. It will collapse in milliseconds. A core collapse supernova will tear through its outer layers. The explosion will be visible from Earth, possibly as bright as the full moon, casting shadows at night. It will be a ghost light seen by every eye on the planet, and then it will vanish forever. The death of Betelgeuse will leave behind a neutron star, or perhaps even a black hole. But the light of that final moment will linger for months, a shimmering relic of a fallen titan. And yet, for all its future violence, there is something sad about Betelgeuse. It is a familiar friend in our sky, one of the few stars given a name in ancient times, revered by cultures around the world, the shoulder of a hunter, a crimson beacon in winter dot. To watch it struggle, to watch it dims, to witness a kind of celestial aging, a once mighty sun, shuddering as it nears the threshold of oblivion. But here's the truly haunting part. Because Betelgeuse is 700 light-years away, everything we see is already 700 years old. Its dimming, its pulsations, even its survival, all delayed by distance. It may have already exploded. We just haven't seen it yet. Every night we look up at Betelgeuse. We are looking into the past, not knowing whether the present has already burned to ashdod. Now, let us turn from this doomed sentinel to something stranger still, a cosmic puzzle wrapped in unpredictability and madness, where starlight behaves like whispers from another realm. Chapter 16. The Whispering Madness of KIC 846-2852 in a quiet patch of the Cygnus constellation. Nestled among the stars that Kepler watched with tireless precision, lies one of the most disturbing stellar mysteries ever recorded. Its name is technical KIC 462,852. But the world now knows it by a far more evocative title. Tabby star. At first, it seemed ordinary. A stable F-type main sequence star, not unlike our Sun, but slightly hotter and more luminous. For years, it glowed with calm persistence. Suddenly, it began to flicker, and not like any star ever observed before. Kick 8,462,852 would dip in brightness deeply, irregularly, and without warning. Not the neat, predictable dips caused by orbiting planets, but wild, erratic plunges, sometimes dropping more than 20% in brightness, lasting days or even weeks, then vanishing again without pattern. It was as if something immense, so many things were passing in front of the star, blocking its light in chaotic rhythms. No known natural explanation seemed to fit. Astronomers, confused but intrigued, began to theorize. Could it be a swarm of comets? Unlikely there would need to be hundreds of them, each precisely timed, and we'd expect to see accompanying infrared heat signatures. Could it be dust clouds? Possibly, but the dimming occurred in a way inconsistent with known dust behavior, and it spanned across many wavelengths. Could it be a broken planetary system? Debris from shattered moons or disintegrating exoplanets, a stellar graveyard drifting in pieces? Or could it be something artificial? One of the most controversial theories, popularized not by fringe thinkers, but by serious astronomers, was that we might be witnessing the signs of an alien megastructure, a Dyson swarm, or light harvesting platforms built by an advanced civilization to capture the energy of their star. The media took hold of the idea. Headlines blazed. The SETI Institute trained its instruments on Tabby's star, listening for signals. Silence. No beacons. No transmissions. But the dimming continued. Years later, the mystery remains unresolved. The star still flickers, though not as dramatically as in its initial discovery window. Its light curves resemble a kind of whispered madness faint, patterns without clear structure, like a language on the edge of comprehension. And the star itself, silent, distant, unchanging, except for its flickers. It's almost as if it's trying to tell us something. Or perhaps it's forgetting something, breaking apart, slipping slowly into chaos. There's a particular unease in how close this star seems to our own. Its mass, its light, its location, nothing out of the ordinary. And yet, here it is, haunting astronomers with data that resists explanation. Tabby's star is not just mysterious, it's lonely. No siblings to blame, no nearby celestial structures to interfere. Just a single star, pulsing in irregular despair, like a mind gone quiet, then briefly screaming. Maybe there is no alien megastructure. Maybe we're witnessing the death throes of a planetary system. Maybe it's something entirely new, something our physics has not yet dared to imagine. Whatever the truth, KIC 8,462,852 reminds us that even in a sky full of stars, the unknown still blinks at us. And sometimes the flicker is more terrifying than the darkness. Let us now turn from this whispered chaos to a different kind of horror, a place where light cannot escape, and the very fabric of reality begins to twist. The haunted core of a dying star gone too far. Chapter 17. The silent collapse into a black hole. Not all stars die with an explosion. Some slip away without a sound. No final burst of brilliance, no lingering glow, just absence. These are the stars that vanish, and when they do, they leave behind a kind of cosmic silence so profound it reverberates through the void. We call it direct collapse when a massive star dies and forms a black hole without a supernova. And it is perhaps the most terrifying stellar death of all. In 2009, astronomers studying the galaxy NGC 6946, the so-called fireworks galaxy, noticed something strange. A star known as N6946b H1 had been shining steadily for years. It was a red supergiant, large and luminous, ordinary in its final stages, but not unusual. And then it disappeared. No blinding explosion, no gamma ray burst, no nova, just a faint flicker of light, and then nothing. For months, telescopes across the world watched, waiting for the telltale brightening of a supernova. But it never came. Instead, the star seemed to fall inward and become invisible. The only thing left behind was a faint infrared glow, possibly from the material falling into a black hole, a subtle heat signature, where once there had been starlight. This event was one of the first observational clues that not all black holes are born violently. Some are born in silence. Imagine that. A star, massive enough to warp space, collapses under its own gravity. Its core implodes. But rather than explode outward, its mass folds into an invisible point. No sound, no light. Just gravitational darkness. From a distance, this death is not marked by fury, but by absence, by what should be there, but isn't, and it's likely happening more often than we realize. Stars, 25 times more massive than the Sun or greater, are thought to be candidates for direct collapse. In such cases, the energy produced by core collapse is insufficient to blow the outer layers away. Gravity wins. Everything falls inward. Time slows at the edge. Light bends. Matter vanishes, and in place of a once burning giant, there is now only a shadow, a black hole. But perhaps the most haunting aspect of this process is that we don't see it. We only notice the missing dot. It challenges our assumptions about stellar death. We are used to cosmic fireworks, supernova lighting up the sky, neutron stars sending pulses, remnants glowing in nebulae. But this is a vanishing act. A death without a cry. What else might be disappearing out there? Are some stars in our own galaxy already gone, their light still on its way to us, masking a grave that formed centuries ago? When we stare at the night sky, we are not just looking at what is, we are looking at what was. And in rare, chilling cases, we are looking at what is already gone. The silent collapse into a black hole is not the end of a star's story. It is the beginning of something more alien, more unknowable, a point of no return, a place where physics falters, a cosmic tombstone with no inscription. From this silent void, we drift now toward something even stranger. A binary star system, so close, so entangled, that one star drains the life from the other. A vampiric embrace among the stars. Chapter 18. The Vampire Twins of SS-433 in the quiet depths of the Aquila constellation. Far beyond the reach of naked eyes lies a binary star system so strange, so violent, it defies easy classification. Its name is SS-433, and its legacy is one of hunger, gravity, and relentless consumption. This is a tale of stellar vampirism, relationship, not of balance, but of slow, painful betrayal. At the center of SS-433 is a compact object, most likely a black hole. Although some argue it could be a neutron star. Its partner is a massive, blue supergiant, bloated and dying. The two orbit each other in a deadly dance, just a few million kilometers apart. And yet, this is not a quiet rotation. This is a feeding. The black hole, or its neutron star, cousins, drawing matter from the outer layers of its companion. Through a gravitational siphon known as an accretion disk, it devours the supergiant's hydrogen-rich plasma. Gas spirals inward at terrifying speeds, heating to millions of degrees of X-rays. But SS-433 doesn't stop there. From this whirlpool of stolen matter, twin jets emerge in narrow beams of particles accelerated to nearly a quarter the speed of light, firing in opposite directions from the disk. These jets don't point in a straight line. They wobble like a spinning top. This motion, called precession, traces a cone in space every 162 days, as if the system itself is staggering under the weight of its unnatural relationship. This is what makes SS-433 so famous sand, so eerie. It is not just a feeding. It is a machine. A celestial engine fueled by the blood of a dying star, spinning, bleeding, howling in the darkness. But here's what makes it truly disturbing. The donor star, the one being consumed, is slowly losing itself. Its atmosphere is no longer its own. It is thinning, warping, spiraling inward toward the mouth of its dark companion. And one day it will be gone. Its fate is sealed. Even if the black hole's feeding slows, the balance is already broken. One twin consumes, the other dissolves. And what happens when the companion is gone? When the disk dries up? The jets may vanish, the system may dim, the monster may sleep. But even in rest, the black hole will carry the chemical memory of what it devoured, its mass forever altered, its gravity made heavier by the life it stole. SS-433 is rare, but it is not unique. Dozens of X-ray binaries are scattered across the galaxy. Each is a story of consumption. Each is a cautionary tale. We think of stars as beacons, radiant and noble. But systems like SS-433 remind us that the universe is not fair. It is predatory. Even among stars, there are monsters now. Let us depart from this parasitic embrace and drift toward something equally haunting, but far colder. An ancient star whose very surface has crystallized, becoming a cosmic corpse of diamond. Chapter 19. The Diamond Heart of BPM 37,093. Deep within the constellation Centaurus. Far from the glittering stage of visible stars lies an object that no longer burns, but still echoes with a memory of fire. It is known as BPM 37,093, though some call it something far more poetic. The diamond star, at first glance. BPM 37,093 appears to be a typical white dwarf, the leftover core of a sun-like star that exhausted its fuel and shed its outer layers. It no longer fuses hydrogen. It no longer radiates heat from its core. But inside this compact remnant lies a heart of crystallized carbon. In other words, diamond. Of a star, roughly the size of Earth, yet with a mass greater than half that of our Sun. BPM 37,093 is dense beyond imagination. Its surface is inert, silent, cold, but at its core, something extraordinary has happened. Under immense gravity and cooling over billions of years, its carbon atoms began to crystallize, forming a structure nearly identical to diamond solid. Ordered, eternal. This star is not alive. It is not dying. It is dead, but preserved. A cosmic tomb turned to crystal, a frozen echo of fusion, a heartbeat encased in mineral purity. The discovery of BPM 37,093 stunned astrophysicists. For decades, they had theorized that white dwarfs could crystallize, but this was the first real evidence. The star even vibrates ever so faintly, like a bell pulsations that allows scientists to listen to its interior using a technique called asteroseismology. From those vibrations, they could detect the solid core within. It was as if the universe had gifted us a chime from the afterlife of stars. Estimates suggest that more than 90% of BPM 37,093's mass may be crystallized carbon and oxygen. It is, quite literally, the largest diamond in the known universe, at least. The largest we've found so far. But there's something quietly unsettling about this celestial jewel. Because BPM 37,093 was once alive. It once burned, fused, radiated life-giving warmth. It may have had planets. It may have had a solar system like ours. Now, it is frozen, a relic, a monument, a crystallized death mask, and this fate awaits our own sun. In about 5 billion years, the sun will swell into a red giant, then collapse into a white dwarf. Over time, its core will also cool and crystallize. Earth, long gone, may never witness it, but the sun, too, will become a diamond in the dark dot. It's a comforting thought for some, terrifying for others. A jewel made from light, buried in cosmic silence. And yet, this is not the final transformation a star can take. There is one more step, one final, chilling possibility. A star that dies not into crystal or flame, but into pure invisibility. Let us now journey to our final chapter, where even memory fades, and we confront a star that should be there, but isn't. Chapter 20. The Invisible Remnant of SN 1987A. On the cold night of February 23, 1987, astronomers around the world caught sight of something extraordinary. Something not seen with such clarity in nearly 4 centuries. A supernova exploding in the large Magellanic Cloud, a neighboring galaxy just 168,000 light-years from Earth. It was designated SN 1987A, and for weeks it shone brighter than an entire galaxy in infrared and ultraviolet light. It even became visible to the naked eye, a rare gift in the age of telescopes. And then, like all brilliant deaths, it began to fade. But SN 1987A didn't just leave behind echoes of light. It left behind a mystery. Because at the heart of the explosion, there should be something, a neutron star, the collapsed core of the original massive star. And yet, when scientists looked, there was nothing. No pulsar, no X-ray beacon, no radio signal. Just the remnant, nebulae, expanding, cooling, haunting, surrounding, a dark center where something should be. This invisible heart of SN 1987A became one of modern astronomy's most profound puzzles. A black hole, or was the neutron star simply hidden, buried beneath thick veils of dust and gas? For decades, nothing conclusive appeared. Instruments scanned the core again and again. Every new generation of telescope brought hope, and then silence. It was as if the universe had performed a trick in plain sight, a cosmic vanishing act, witnessed by thousands, with no one able to prove where the star had gone. And yet, the clues were there. In 2019, new data from the Atacama Large Millimeter Array ALMA began to hint at something subtle. Deep within the center of the expanding cloud, there was a hot spot, a dense, warm clump of dust, not glowing, not pulsing, but warmer than its surroundings, inexplicably so. It wasn't proof, but it was a whisper, a shadow of presence, a suggestion that something might still be there, obscured, hidden from sight, perhaps a neutron star, young and quiet, still cocooned within the debris of its own birth. If true, then we are not just observing the aftermath of a star's death. We are witnessing its afterlife, still forming, still emerging. Like a ghost not yet ready to show itself. There is something deeply poetic, perhaps even tragic about SN 1987A, a supernova seen by humanity in real time. A cosmic obituary, still missing its name, and maybe, in time, the fog will lift. Maybe one day we'll detect the spin of that hidden neutron star, or hear the faintest beat from the darkness. Until then, it remains a stellar phantom, suspended between existence and legend. So ends our journey through the universe's most haunted stars, a tour of flickering embers, vanishing lights, frozen hearts and silent screams. Not all ghosts wear chains or dwell in abandoned houses. Some drift through space, flickering gently in telescopic vision, whispering stories of violence, solitude, and slow decay. And when we look up into the night sky, perhaps we'll wonder which stars are truly alive, which are already gone, and which are haunting us still. The stars that haunt the night as we drift back from this journey through the cosmos. A quiet settles in a hush that only the universe can provide. We've traveled beyond the warmth of familiar suns, beyond the glittering arcs of constellations we thought we knew, into the dim places where light fades, where silence lingers, where stars remember what we have forgotten. We have seen giants gasping in their final breaths, pulsars blinking like Morse code in a language we don't understand, stars ripped apart by invisible hands, and frozen remnants whispering stories long after their flame has gone out. Each of these haunted stars tells a truth that even in a universe defined by light, it is shadow that gives shape to mystery. That even in the vast cold, memory survives, and gas, dust, and gravity, and that even when a star dies, it never truly disappears. The cosmos is filled with echoes. Not all of them are loud. Some are barely audible. Some flicker once and never again, but they are there. And if we listen, if we watch closely, we may begin to see the patterns in their passing. Perhaps in the stillness of night, when the stars above seem to hold their breath, we can imagine these haunted suns, not as frightening, but as witnesses. Witnesses to a deeper story, of birth, of destruction, of rebirth, of a universe in motion, both terrifying and beautiful in equal measure. So rest now, let your thoughts drift as the last embers of distant starlight fade behind your eyes. For somewhere out there, a star just blinked, and it may never open its eye again. Good night, traveler. May the stars guide you gently into dreams, haunted but never alone.